Okay, this will be a small rant, or maybe not that small, but a rant about this board, SparkFun Thing Plus. I mean, it's not about the board itself, it's mostly about the processor it uses and how difficult it is to implement a Bluetooth application. I'm personally aiming to implement an HID, so basically an interface device, so basically a Bluetooth keyboard or something like that. And the thing is that implementing that on this board is a nightmare. It's a total nightmare, and like I do recognize that it's in a way a function of my experience with Bluetooth, embedded programming and all of that. I would consider myself to be pretty experienced when it comes to embedded and low-level programming, but I can't say the same thing about Bluetooth. Bluetooth is something I'm new to, so it might be like maybe my opinion isn't that valid, but anyway, let's rant a bit for a while, because I have spent the last 3 or 4 weeks trying to implement like the basic Bluetooth example, and it hasn't been that great. So basically the board is using an Apollo 3 processor by a company named Ambiq, I guess. Yeah, that's the processor. It's a pretty nice one. If you read the description, it works with 48 megahertz, which is nice, and it's low power. That's like the sell for it. It's a very low power device. So basically this board by SparkFun integrates that processor. So under this like metal shielding there is this chip, and this small PCB is soldered on this bigger PCB, and I guess that bigger PCB can be called the Thing Plus. And the board itself is nice. It supports a LiPo battery, and it can charge it, and it can run out of it. It has a microphone because it's like the one of the examples is speech recognition and processing, which is nice, I guess. It's a nice board. The problem, it uses like the USB-C, which is also nice. The board itself is cool. My gripe with it is the software, which is the software stack, the SDK, which is less than perfect. So basically that's the project structure I'm working with right now. So basically that's where do I start with that? Like the source folder has the main file where I implement everything, and there is also the Ambiq Suite SDK, and that's actually a repository for SparkFun. So they basically host their own copy of Ambiq SDK, which well, I guess it's nice, because why it's cool is that it basically references the another repository, the board's SFE repository, which holds the board support functionality. So basically this is the Ambiq SDK, and then there is board's SFE submodule, which brings the functionality for the specific boards SparkFun is selling, which I guess is nice. It also gives you like a common folder where you find an template, so that's like all of the necessary things you need to start with the board, like the code. The problem is that this example is very low level, so it basically brings in the very simple HAL level support. So there is basically okay, maybe that will be easier like so. So there is basically several parts to the software that are of importance. So let's move this window here. So first of all, you have the CMSIS, I guess. I don't know if that's the way to pronounce it, spelling every letter, but that's basically the architecture level, ARM architecture level code. So you shouldn't worry about that much. Like it's not peripheral level, so it's like the architectural ARM level code. It's pretty low level. You shouldn't be worried about that much. I guess there is this MBQ micro subfolder which extends this with, I mean, that's some assembly code. Then there's this system something. Yeah, the idea is that you and I, we shouldn't poke around here. It's not the goal. It's too low level to actually be bothered by it. Then there is the boards SFE, that's the SparkFun submodule, and there is boards. So boards provides a support for specific boards, evaluation boards for specific processors, and boards SFE expands on this idea and brings the BSPs for specific boards they sell. For example, that thingy here, Artemis Thing Plus, or SparkFun Thing Plus Artemis, Jesus, the naming. What is also of interest is the HAL level library. So if you go to MCU, that's where the HAL layer lives in. So basically, at this point, what's important is that it's pretty easy to implement like the CMCSIS plus HAL, which gives you a plus the BSP, so the board support package, or however it's called. For if you go to boards _SFE Artemis Thing Plus BSP, you will find those. Like those are the main BSP files. Board support package, oh, that's what BSP stands for, jeez. And there are the pins which define like how the smaller PCBs pins and the Apollo chip pins translate to those pins, to the headers, and what they support, what's their function, role. Here you will find the actual library. I have rebuilt it with some debug flags, which I will talk about later too. That's why I have those artifacts here, but that's the library you usually link to when you build the firmware. So that's the BSP layer. And so basically at this point you have like that gives you a full control over the board, but on a pretty low level. So basically HAL library gives you access to like the typical things you will find on like Arduino boards, like UART, SPI, and things like that. And it gives you the HCI layer of Bluetooth, which is a pretty low level layer. Basically that allows you to communicate with the Bluetooth controller, which is way too low of a level to implement something. Why? Because if you go to the ARM Cordio stack website, you will actually, well, I'll have to find the proper picture. Oh yeah, I think that will that work? Yeah, let's say this one. So when you want to implement like a Bluetooth application, what you're interested is that higher level functionality, because like all of that whole stack, HCI, L2C, SMP, ATT, DM, like they are like described here, what they mean. That's a lot of code. You don't want to implement that. Like it's hard. I mean, maybe you want to, like you do you, but it's hard. There's a lot of work involved in it. It's not easy. It will take a lot of time. The HCI level is implemented in HAL level. That's because that's actually like the chip level communication between the Bluetooth controller and the actual CPU. So they basically the Bluetooth controller, which like sends the radio data, communicates with the CPU via the HCI. And there are other layers on top of that, like L2C and things like that, that like expand that, and in the end you can pretty easily communicate with the Bluetooth module. So the problem is that when you have like the HAL layer, you're at the HAL layer, you can communicate with the Bluetooth chip, but that's hard. Like that's not easy to do. Like there's a lot more code that needs to be written in order to actually like make it a USB Bluetooth device. So on that level, it's not that easy. If you actually want to go further and implement a proper like Bluetooth device, then you have to go into third-party folder, and there you will find the Exactal folder and the micro ECC. So micro is ECC is for security, like generating keys and things like that. Exactal is another bag of complication. So Exactal, which is, well, if you Google for Exactal, what you'll find is probably like that's one of the few things that I found on the internet about Exactal. Is I'm looking for a specific sentence which says that Exactal has been bought by was it bought, or I don't know, well, it has been acquired by ARM. Yeah, well, it should be somewhere here. Anyway, it was made by Vicentric, and I guess they have created the Exactal stack, and it has been bought by ARM, and nowadays this you can find it as the Cordio stack. That's why it's like relevant for us, ARM embed Cordio. That's like the whole Bluetooth stack that ARM provides for developers. So it's another big bag of complication. Why is that? That's because first of all, since Exactal doesn't exist anymore, it's probably the Cordio nowadays. I would probably assume that AmbiQ SDK uses an out-of-date version of that software. Like I mean out-of-date, like the old one. I wouldn't say out-of-date, old one. If it's called Exactal, why would it be? If that doesn't probably exist as a brand, as a thing, it's a Cordio nowadays. I don't know. Maybe I'm just like guessing and stretching. Don't know. Anyway, if you go there, you will find several parts to it, and that's where it becomes complicated. Well, where to even start? So the interesting part is, first of all, VS Core, and that's in the end it goes down to WSF. So that's WSF, and that's wireless software foundation, I think. And what it is, it's an OS, it's an operating system. So maybe let's so WSF brings you an OS, which is where I understand why. That's because implementing all those functionalities is not easy. Like, there's a lot of moving parts, and I understand why something like it's a very simple OS is necessary. What bothers me a lot, for example, is that there is duplicated files. So basically you have the ambq folder and the generic folder, and in both you will find WSF OS, and in ambq you'll also find it. And there is a common folder which is like common functionality, an include folder which like also is shared. I think that's not even true. I think like some of those might be duplicated, like WSF math, I think, which is no, I might be mistaken, it's not math, but something else. I think something else duplicates those files. Anyway, common and generic and ambq duplicate some files, which is, I would say, a bad idea. Like, it's forked for ambq and generic. Why is that? That's because, like, well, obviously there are some things that they wanted to work on their own platform, on ambq processors with FreeRTOS, for example. But still, I don't think it's a good solution to duplicate those files. And like sometimes, like the changes between the generic and ambq folders are small, or I think, if I'm not mistaken, there are some where they don't differ at all. So basically, generic, I think, has the WSFOS int.h, and in generic you also have int.h, and I think they don't differ at all, if I remember correctly looking at my notes. So I'm sorry if I'm wrong, but that's not the point. The point is that like forking that into two is a bad idea. Like, now ambq has to maintain their copy, and as I say, maybe that was the best solution for this problem. Usually it's a bad code smell when you do something like that, but maybe this time it's like how it should be. Anyway, forked for ambq, which I find it like you have to link to a proper files. Maybe not that big of a deal, but you can't expect everything to work, and that's a bummer. So for example, let me find this. Oh yeah, that's is it a perfect example? Maybe not a perfect one, but if you, for example, open up the trace file and then you do the same, so the one on the left is the generic one, and one on the right, let's open the ambq one, so it's going to be trace.h. So a lot of those functions weren't defined, they were empty defines. I have added the definitions, and I have saved it as a patch, and I basically apply it every time I compile, which is also a bad thing. You don't want to do that, but that shows that the code quality isn't the best. Like, it provides you all of those functions, and those functions are used in the WSF code by basically, there is a flag that you have to specify to turn on the trace messages, and those don't work if you specify that flag, because those messages aren't defined. Cool, I guess. I mean, I don't know what was the reasoning. It's not hard to implement them. I don't know. Again, don't want to be particularly judgmental, but it is a pain to then like find this in this code, those missing pieces, implement them, save them as a patch, keep the patch, because I don't want to diverge from the original SDK in a hard way with like repository commits. because I don't want to later like mess around with merging things and forking and all that crap. So I save them as a patches, like I basically have a patches folder here, and I apply those patches when necessary. I also apply patches to the libraries I link to in order to turn on the debug flags and rebuild those libs when I need to. Anyway, this is gonna be like a long rant, and I'm sorry for that. But well, I don't know. I hope in the end it will help me and you to make something work. So anyway, that's the OS part. This OS isn't that complicated, but there is like examples are pretty poor, and like for me, like creating an working, it's still not working, but like a sensible example, sensible code with the WSF and all of that took me a while to figure out. What's also important is that here in this folder you will find like HCI devs and things like that, and there is also a layer HCI. Yeah, I think it's here. So here in exactl HCI folder you will find HCI driver Apollo. That's because basically the HCI layer, HAL layer, has to be interfaced with the WSF Cordio stack, because they have their own specifications for that and their API. So the MBQ prepared like a set of files that glues those together. The MBQ is interfaced with this part, which again, more complications. I get it, in a way it needs to be done, because how else would you do it? But there's like a lot of files. It's hard to keep track of. But again, maybe it's about my experience with it. Maybe I'm just a pretty slow person to learn. I don't know. But like if SparkFun wants this board to work as a Bluetooth board, and I like one of the things SparkFun pushes is using it with Arduino core, because they implement an Arduino environment for this board and their own bootloader and all of that. Well, maybe then it's certainly not a priority for them to provide low-level examples using HAL libraries and all of that. But I personally don't want to use Arduino level things, and I would appreciate to be able to implement an example with less effort, like easier. It's complicated, it's hard. But anyways, if you go into apps folder, you will find a lot of examples of apps, like HID app, for example. Unfortunately, this example, again, it's hard to judge it, but this example seems to be missing some pieces in order to be able to compile it and actually run it. Like, okay, that's not. I'm sorry, I'm mistaken. Like, this part is not an example itself. This is like a handler for HID app, because if you again go to the Cordio website, you will find that they provide something called apps. Yeah, so there is this app framework, profile services, sample applications. So basically that's another layer on top of all of that H2C, HC, all of this. So we've got this, and that's like Bluetooth stack, let's say, and then you have the app framework. Oh, and this one is complicated again. It's based on top of the WSF OS. Yeah, here it is. It's a simple OS wrapper. blah blah blah. Yeah, this documentation, I would say this website is bad. It's a bad documentation. I don't know, maybe there is a place where it's, maybe I'm looking in the wrong place, I don't know, but maybe, I don't know, click here, no, that's what take me here. Oh damn. Yeah, it's not good. I mean, it's not good partially because I don't think it relates to the version we have here. Here it's the exact little older version of that code, while Cordio is probably updated and different. And you, like, looking at some files, you will find headers which say, oh, it's made by ARM in 2018. You will find files that don't say ARM and they say 2015 or 2013. Yeah, like the one I'm looking at right now, the HID app, it's ARM. If you look here, it's ARM 2017. Not that bad. There are way older files here. So I think the documentation isn't necessarily that good for this case. Also, it's not good altogether. It's a very rudimentary, a lot of words and trying to describe their ideas, but like, I don't know. It's just a lot of abstractions, and abstractions make it hard to understand things, even though that's not what abstractions should do. Whew. Anyway, so looking at those here, those are like apps that allow you to implement what you need to implement. There are examples here in Apollo 3 EVB examples, and you will find some here, like those examples are of interest. Here you will find that they say Cordio in the name, so that points to the fact that they are like basically using the they assume that they are using the Cordio stack, and those examples are very helpful. I would say they are helpful. Like some of the things here are like the structure of those files actually are what you should aim for. I'm sorry that I'm scrolling so fast through it. Like I'm not here to show you the code itself. I will post a link below to my repository where you can explore it more, and maybe I will make another video in which I explore the structure of the code better, because some things, like, it's hard. I mean, I'm complaining in order to make it work, but without actually explaining my problems, it's hard to make it work. Like, I don't expect anyone to solve my issues if I don't like explain what those are. But yes, again, examples, and like for example, power cycle. Let's go for power cycle, and this one. Yeah. So for example, other examples. I don't think they implement. Let me check it. No. So other examples, like other Cordio examples. So let's do takes power control, and let's go here and let's go here. So that's the main loop. That's where the OS dispatches the tasks to specific handlers. What is interesting is, for example, the interrupt service routines. So you have to override those functions. They are defined in a startup GCC file, and you have to. Those are weak symbols, so you can override with your own functionality. So you have to remember about those. Like, I have missed that for a while, and it was hard to figure this out. That I mean, I don't know. Again, maybe I should have read those examples more throughoutly. But here, for example, like this, there is like a continuous timer running, and it's used to. You can see it here, actually. Set next wake up and update scheduler timers. Update scheduler. First of all, there is like scheduler timer init that inits the continuous timer and a timer for interrupts for when the board should wake up and handle a task. And update scheduler timers basically updates based on the time that has elapsed, and the set next wake up basically uses the time to wake up and handle an event. So So basically, like, they are not directly used by each other, but they are interconnected. Like update scheduler timers updates the WSF OS timers, while set next wake up actually schedules the next wake up for the processor to handle an event. Oh, then I'm sorry, like, I know it's confusing, there's a lot of moving parts, and I hope I will be able to explain it better soon. But I think, like, if you go for the Cordio tag example, yeah, it also implements those ISRs. So at the beginning I was missing those, and that's on me. Like, I should have had them in my code, but I slowly got there. But it was like a long, painful process. I used the debugger at the beginning, like the SWO output, the JTAG or the SWD interface for programming and debugging, like the ITM pin didn't work, so it's like a better, like SWO and ITM, those are like ideas connected to a better debugging output. So basically, that's like embedded Rust. Why okay, it's like someone's oh, I have actually read that that this article, and it's pretty useful, and it explains well what it is. It's basically like sending debug messages through like a better debug port instead of doing that through UART. Yeah, so those examples here maybe aren't that bad, but there is but in order to understand what's going on here, you have to spend some time. Like here it turns off like some portions of SRAM memory. You probably don't want to do that, might not want to do that, you don't know at the beginning. There is no HID example, so I know I'm complaining about like my specific problem, but that doesn't change the fact that my code still doesn't work, and it's hard to establish why. So here are, for example, those symbols that are override from the startup GCC file, which is like a startup file which defines what happens in when the processor boots, basically. Anyway, for example, what I don't know if I'm doing it correctly, but one of the things that I noticed is that in order for the application to start advertising, I think this function needs to be called, like the security keys need to be generated, and then this event is posted into the OS queue, which then actually, if we go into, I'm gonna leave the my main file on the left open, and let's go here in the HID app. At the bottom you can see the file path and the file itself, and here that's like the HID app, and it has a HID app handler, well, more precisely something that processes the messages, and here it actually has this message, which basically starts the HID app setup, which I wanted to do. Like, that's the only place where this function is called. I wanted it to be called. Why? Because that's where the advertising starts, and that's what I want. I want to start advertising as a peripheral device. So that's why I found this this line in one of the examples. I think I don't at this point I don't understand. I don't remember. The problem is that okay, that works well. It triggers this. This goes into advertising start, and then it hits this app advertising start. I hope I'm like, oh yeah, and that's where it should start advertising. DM adv start symbol is defined in a library. Well, I don't want to close that one, so let's go to here, and the library I'm talking about is where is it? I think it's somewhere here. Yeah, stacklib. And it's a pre-built library. It doesn't have any debug symbols, and I can't rebuild it from what I know. There is like no makefile. Other libraries, like for example the HAL library, if you go here, HAL GCC bin, you have a makefile, and it's pretty easy to rebuild it with debug symbols, which is very useful because then you can step through it. Unfortunately here I can't. Like this symbol is like defined in that library. This function returns. I don't know if it succeeds. It doesn't return any like return value. Yeah, I don't know. There's a lot, like that's my biggest issue. There's a lot of almost reverse engineering this code, like trying to figure out what to trigger, and there's like a lot of moving parts. If you look at my main file, there is this exactl stack init. That's a function I took from an example. And there's a lot of handlers that are registered in the OS. So imagine those being like processes that are handled by the OS. And there is like 8 of them, I think. And every handler handles a specific message, it might be woken up on a timer. Yeah, and I basically copied that function. I don't know what's necessary and what's not necessary for my needs. Here is the security init, like for example security ECC init. Cool. Do I need then to call this function, generating key? Do I need to specifically call it? I don't know. I mean, I want to, because I want to post this message and start advertising, and it seems that I need to do it. But yeah, I don't know. And the problem is that it's hard to, I don't know, and it's hard to find out the answers. I haven't found a good documentation. There is not a lot of people around that seem to implement this in this way, in using like the low-level stuff, the WSF OS and all of that. So basically what I have right now is an example in which it works, but it doesn't advertise. Like I can't see the device on other devices. I feel like I'm close to it. There is a lot of things that it seemed to work, like the debug output works because let me show you the makefile, because in the makefile, my makefile, when I learn to type, so there is this SWF trace enable. So by default you can set that flag. Cool. That won't do you any good because basically a lot of, as I mentioned before, a lot of those trace functions aren't defined, which is a bummer. Or here I have WSF OS tag. That would be nice to have too. But if you go to the SDK, you will then see that, as I mentioned before, WSF is split into generic and ambigu, and generic OS has like uses this flag. Like I don't know if that would be that useful. I didn't explore it that much because like here it uses this flag, it does something with it, while the ambigu version doesn't at all. Like this symbol is not even defined here, like it has been deleted. So cool. Like what's the point of like forking and removing functionality, like only to make it harder? I don't know. Like I get it, maybe that's not that useful and they decided to delete it, and I just don't know it, but it adds to confusion if you fork your code that way. If you fork things like third party libraries, you want to adapt it to your hardware. I get it. It's not an easy problem to solve. I don't know if that's the way to do it. I would say it's not, but maybe I'm mistaken. So yeah, well, I think that might be it for now. Like, I don't think there's it's useful to rant anymore. I will probably make another video which explains it a bit more, like maybe explains the parts to it, and maybe that will help someone else, and maybe then someone else will be able to make their code to work, and together maybe we'll be able to figure it out. As I said, like, I don't want to criticize SparkFun or MBQ itself. Those problems are big and hard to solve. And I think the board itself is very cool. I really want to use it, but I have spent like 3 or 4 weeks now working on it, and I'm still not there. And I know that if I went with something more mature hardware, I would probably be able to make it work very quickly, like maybe NRF chips, Nordic. Yeah, those guys also produce like Bluetooth enabled chips, and I know those are more mature, and so maybe it would be way faster, way easier. Oh jeez, why is it loading so slow? Well, never mind. Maybe that would be the way to go for me for now. I want this board to succeed. I want to make it work. I think it's an interesting board. Yeah. So I don't know, like I will try to make more content that helps and explains a lot, and maybe we can push it forward. And I also want to thanks SparkFun, because I helped, we together like solved the SWO ITM output issue through like on GitHub on the boards_SFE here in this repository, and I really appreciate how quickly they respond, and that they respect your opinion, and that they respond quickly and really try to solve the issue and make the experience as best as possible. I also recognize that they are not responsible for ARM's code or ambiguous code, but that doesn't change the fact that as a customer, as a consumer, I would like to be able to use capabilities of this board, and I know it's way harder to I mean, it's just a big expectation to assume ARM or MBQ will put the same amount of effort. SparkFun is one of those companies that tries to be community friendly and push it all forward. So I don't put responsibility on them, but I guess it's also in their best interest to make this work well. Okay, I think I'm not it shouldn't be that long, so I think it's almost 45 minutes of me talking. Anyway, okay, I'm sorry to be that long. Thank you if you watched it. Hopefully we can fix it. Yes, thank you. Bye.